Now, I missed the video. I messed up here. But where you see that hump up going up in the air up there, that's where we were on outside air. And it was 75, 76 degrees, 77 degrees. It was taking in fresh air. Then I closed it and put it in recycle. And I closed the doors and windows. And the intake air temperature has dropped because it's no longer taking the air from here. It is taking the air from inside the recycle from the earlier video where I showed you the inside air. So the cabin temperature is dropping right now. So the cabin temperature of the recycled air is now down to 61 degrees. And as you see, we have a steady temperature of 42 degrees coming out of the dash. It hasn't changed. You can see that there's no load. Now you see bubbles. Because it does not have to flow that much refrigerant. And if you can hear the compressor, take a listen. You can hear the fans going, but the compressor is not winding that much anymore. So now, there's a very, very slow, because this is a variable speed compressor. The compressor does not have to push a lot of refrigerant because there's no load. And you have to understand this. When there's a load, you heard the compressor wind up more. You've seen so much flow in here, it actually started to, it turned clear. It backed up with a solid column of refrigerant. So if we go back up here, let's look at the temperature of the compressor because we have no load on it now. Look at our liquid line temperature. It dropped from, what was it, 142, 145, something like that. It dropped down to 140, 126 because there's no load, there's no energy. There's much less energy being absorbed by the evaporator because only 61 degree air is recycling within the cabin, so it's not working hard. So the computer tells the compressor to slow down. It says, I don't need so much refrigerant. So it slows down the compressor. But it keeps the level, the temperature, steady and even coming out the dash. Whether the compressor was going faster, 4,000 RPMs, or like right now, maybe 1,100 RPMs, the temperature is still exactly the same. What else can I show you? Let's hook up the pressures. Okay, so now let's show you pressures. I did not want to show you pressures because I don't want you to get hooked on pressures. Temperatures are actually more important, but for the sake of everybody who likes pressures, we will hook up pressures because I know there's those who will say, I want to see pressures. Okay, so let's get over to this one. It's 127, so if you went to the PT chart and that refrigerant fill level is correct, it should correlate on the PT chart, 134 PT chart, and look up 126 degrees Fahrenheit and cross-reference that to what we get for pressure. Well, look at 126 degrees. Is it 126 degrees or 27? Almost equal. 26 degrees, 128 psi. Now let's look at the low side pressure. And the low side temperature is 51 degrees. But remember, I'm on the discharge line of the compressor. I'm not on the liquid line. I'm going to show you what happens when I switch. You're going to look at the superheat. Trying to do this with one hand and hold the camera. Sorry guys, I gotta put you down. Shit. There we go. Could not do that with one hand. 30 psi. Temperature 51 degrees. Superheat, 16 degrees. Go to the PT chart, and a lot of you guys don't know about superheat and subcooling. I'm going to recommend you some different channels about that, but you're going to use the PT chart and you're going to discover why this temperature with this pressure comes up to this superheat. It's real simple. All right, let me move the high side temperature probe. That's giving us 127, and that's why we have this impossible subcooling. And we're going to move that over to its correct location. If I could do it without cutting my fingers on when the engine starts up and the pulley starts to move, or the fan doesn't catch my fingers. There we go. So we're going to take that off of there, and we're going to go on to the liquid line. You know, I'm on the liquid line. That liquid line is hooked up right here to this. Did I just do that right? Yes. We were at 127, and you see we're following right now. Now, this temperature should correlate, if it's full and properly functioned, they're supposed to correlate, except you got the superheat here. Now, you're going to look up the mass formula and go to the PT chart, and you're going to figure out how does this come up to 12.7 with this pressure and temperature. You are going to teach yourself this. I'm not going to tell you. For you guys who want to know, I'm going to tell you to go to Brian Orb's YouTube channel for HVAC School for Techs by Techs, and also Craig, and I'm going to butcher his last name, but it's an Italian last name, like Craig Macchialo or Macchiano or something like that. Sorry, Craig. Those are two examples, and you're going to look up their classes, their little courses where they teach you about superheat and subcooling, and then you'll have a better understanding of how to use the PT chart. If you have old style analog gauges and you don't have digital gauges, you can do this yourself with a good set of temperature probes that you could clamp on, and your analog gauges will give you the rough estimate of what your superheat or subcooling is, depending on whether it's an orifice tube system, cap tube system, or an expansion valve. So let's put some load back up here, and we're going to hear this compressor wind up again, and we're going to see that refrigerant flow increase. All right, so let's do that. So I'm going to open up the doors and window. I'm going to put it on fresh air, and we're going to grab some of this warmer air out of here. Go back to climate. Go back to fresh air. There, we're now on fresh air. Now we're going to put some hot air over that load. I'm going to keep the door open because I don't want that cool air to go back. I want to get rid of the cold air. I want a constant flow of warm air. And we can see this jump up. See if you can listen for the compressor. I'm sorry, the engine is running right now. We're gonna have to come back and listen to compressor. But we can see there's a load that's going over the evaporator. The pressure transducers and the temperature sensors in the circuit are gonna tell the compressor, it's gonna say, hey, I have this heavy load, and we're no longer keeping the passenger comfortable. So Mr. Compressor, start spinning yourself up faster so we could move more pounds of refrigerant across that metering device, that expansion valve. The more pounds of refrigerant, every pound of refrigerant can hold so many BTUs. We need more because we just got a higher temperature load going over the evaporator. And right now it's having a hard time keeping up. It moved up to 47 degrees. Now I could start hearing the compressor. I'm sorry, the engine's going, so I don't know if you guys can hear the compressor. Compressor is getting louder because the computer is commanding the compressor to turn faster, to move more pounds, so they can bring the temperature back down to make the passenger happy. So look, we're at 47 there. I can hear the compressor spinning faster, and look at the low side. Look at the temperature is going down. It just went down 1 degree. As the compressor is spinning faster, more pounds are being moved to do more work. And look at the pressure is going down. the compressor speed is going up. $46, $45, $79. So now I'm going to recover the refrigerant, and I'll let you know on the next video how much refrigerant I recover out of here, because this system should have a maximum of 480 grams. Can you hear the compressor? The engine's off. Do you hear that? The compressor is spinning really fast now because it's continuously getting this hotter and hotter air. 80 degrees now. And our temperature has dropped to 44 degrees. It's trying to get back to where it was. Where was it? It was happy at 43 degrees. It's trying to get back there. When it gets back there and it starts leveling out and it feels that, okay, I'm satisfied, that's all I need to do, it'll start slowing down the compressor. If there's not more load, keep going on the evaporator, and it could keep up. So let me stop this video where it is. I'll do a recovery and I'll show you exactly what I get out.